right, in 5.1, we are going to talk about angles and their measure. So the first part here is just a lot of vocab. I've got some blanks on the paper that you can fill in the missing words. So first, let's just talk about an angle. So a ray is a portion of a line that is made up of a point, which is the end point, and all points on the line on one side of the end point, right? So we know that a ray is just essentially a line that continues on forever in one direction. An angle is formed by rotating a ray about its endpoint. We say that the angle's initial side is that ray's original position, and the terminal side is the ray's position after rotation. Okay? That endpoint is called the vertex. Okay, so in this example, right, if this is the initial side and I rotate the ray, here's the terminal side, this point right here, that endpoint is the vertex. Now, we say that if we rotate the initial side counterclockwise, we get a positive angle. And if we rotate clockwise, we say the angle is negative. Now, another thing here, if two angles have the same initial and terminal sides, they are coterminal angles. So here, if we say my first angle starts here and goes here, and then my second angle starts here and rotates one full rotation and then all the way back to here, those two angles have the same initial and terminal sides, so they are coterminal. Now, one other thing I want to point out here is the traditional variables that we use for angles. Usually we use Greek letters to describe angles. So in this visual, they have theta, alpha, and beta, right? Usually we use X, Y, and Z for unknowns in lots of other situations. But for angles, usually our variables will be Greek letters. Okay, that's just a tradition. Um, so the next little set of vocab is if we put an angle on the coordinate plane, we say that it is in standard position if the vertex is the origin and the initial side is the positive x-axis. Okay, and that's what we're going to look at, our angles here, right? We're going to say that the vertex is at the origin, the positive x-axis is the initial side. So this angle, since this is going clockwise, we would say that this is a negative angle. And then we say the angle lies in a certain quadrant if the terminal side is in a quadrant. Okay, so in this example, this is quadrant 2. So we would say that this angle lies in quadrant 2. Okay, and remember the quadrants are 1, 2, 3, 4, right? So this angle lies in quadrant 2. Then finally, we would say that an angle is quadrantal if the terminal side lies on an axis. So in this example, right, this would be a positive angle, right? And we would say it's quadrantal because the terminal side lies on the y-axis down here. All right. So let's practice drawing a few angles in standard position. All right. So first, if I want to draw a positive 60-degree angle, we're saying that always we're starting on the x-axis, right? Now, I know from here to here is 90 degrees. So 60 degrees is about 2/3 of that, right? So we're not going to actually measure. We're just going to kind of eyeball. So we would draw our angle like this, okay? We want to make sure that we are drawing this little arrow to show what direction the angle is going in, right? If I just draw this line, that doesn't tell me what direction. I could have gone all the way around here. So we need to make sure that we are drawing an arrow showing what direction our angle is going in, all right? So if I want to draw a 135-degree angle, well, again, I'm starting here, and then, well, from here to here is 90, so then I need to go an additional 45 degrees. right? 45 would be halfway, okay? The line's not real straight there. And then again, we need to make sure we're drawing the arrow showing the direction that this angle is going, okay? The next one, we've got negative 240. So first of all, the negative sign tells me that I'm going to be going in this direction, okay? So if I go negative 90, 180, then I know it's going to be somewhere in quadrant 2. So I would have to go an additional 60 degrees in this direction, right? So that's, again, 2/3 of the way from 180 to 270. So here's where that angle would end up. And again, we need to make sure that we're showing that it's going in this direction, okay? The final example is 405, okay? We can have angles that are greater than 360. That would just mean that I'm rotating more than one time around, right? Technically, we could rotate as many times around as we want. We could have angles as large as we want. So if we think about going counterclockwise, 90, 180, 270, 360, well, my next 90 degrees would be 450. So I know it's going to be somewhere in here, right? That would actually just be an additional 45 degrees. So that would end up looking like that. So then we need to show that we went a full rotation around. So I need to draw this like this, okay? That's why this is super important to draw when we are drawing angles, right? We need to make sure that we are showing how far we are rotating that terminal side, all right? So the next thing is to talk about using degrees, minutes, and seconds, all right? Traditionally, this is how degrees were used, okay? Instead of using a decimal, we would say, how many degrees, minutes, and seconds. So if I want to convert something like this, 17 degrees, 41 minutes, 13 seconds to decimal degree notation, right? If I want to put that into 17 point something degrees, what I want to think about is, well, 1 degree is equal to 60 minutes. The same as 1 hour is equal to 60 minutes. 1 degree is equal to 60 minutes. So if we think about 1 hour equaling 3,600 seconds, 1 degree would also equal 3,600 seconds. Okay, so if I want to convert this, what we're thinking about is each minute is 1/60th of a degree, and each second is 1/3600th of a degree. So to convert this just into a decimal, I'm going to say 17 plus 41/60ths, or 41 times 1/60th, plus 13 seconds would be 13 times 1,000, or 1 over 3,600. Okay, this will let me convert this into a decimal. Okay, so if I put that in the calculator, this is what I end up with. Okay, so 17 minutes, or I'm sorry, 17 degrees, 41 minutes, and 13 seconds as a decimal would be 17 point, and the direction said round to 2 decimal places, so 17.69 degrees. All right. Now, if we want to go the other direction, if we want to convert something like this into degrees, minutes, and seconds, well, what we want to do is look at the decimal. Okay, so I know that this is going to be 67 degrees. Now, this 0.526, okay, I want to see how many minutes that is. Well, to do that, I want to multiply 0.526 times 60, okay? 0.526 times 60 minutes is going to tell me that 0.526 of a degree is 31.56 minutes. Okay, so I'm going to say 67 degrees, 31.56 minutes. Well, now I want to take this 0.56 and convert that to degrees, right? So this is 0.56 of a minute. I'm just going to take this and multiply it by 60 again to get how many seconds. Okay, so 0.56 times 60 is 33.6. Now it said round to the nearest second, so I'm going to round that to 34 seconds. Okay, so my final answer would be 67 degrees, 31 minutes, 34 seconds. Okay, and we use 1 tick to denote minutes, 2 ticks to denote seconds. Okay. Traditionally, right, we see this a lot when we're talking about position, right? If we're using latitude and longitude, you may see this notation a lot, right, with degrees, minutes, and seconds. The next idea is a radian, okay? In this class, we're probably actually going to deal more with radians than we are with degrees. Right? We know that in an entire circle, there are 360 degrees, right? Or in an entire rotation, there are 360 degrees. We can also measure the distance around a circle using radians. Radian literally means one radius length, right? So a radian is a radius length. And remember, a radius is the distance from the center of the circle to the edge. Okay, that is one radius length. So a radian is just if I were to take that length and measure that distance around the edge of the circle. Okay, now this graphic over here shows if I were to continue taking a radius length all the way around the edge of a circle. It turns out that in an entire circle, we can fit a little over 6 radius lengths. And that's true no matter how big the radius is. Okay, the radius, if the radius could be 2, the radius could be a million, right? No matter what, the radius will always fit a little over 6 times around the edge of the circle. This is where pi comes from, right? The ratio of the number of radius lengths to the edge of the circle is always exactly 2 pi radius lengths. Or we can say that if we want half of the circle, that's exactly pi radius lengths. Okay, pi is 3.14. That's 3.14 times that the radius fits around half of a circle, or 2 pi times that it fits around an entire circle. So we can use this to measure angles as well. Okay, so instead of saying that from here to here is 180 degrees, we can say that that angle is just pi. Or if I want a 90-degree angle, instead of saying that's 90 degrees, I could say that that is half of pi, right? Or pi over 2. So in this class, we're going to use radians a lot to measure angles, and we'll talk a lot more about that here in a couple of videos. The last idea that we're going to look at today is just converting between degrees and radians. Okay, so we just talked about the idea that 180 degrees is equal to pi radians. So if I want to convert a degree measure into a radian measure, what I want to think about is, well, degrees would equal pi over 180, right? If I just divide both sides by 180 here, I would get pi over 180. So whenever I'm going in this direction, from degrees to radians, I am just going to multiply by pi over 180. So times pi over 180. So I would get 30 pi over 180, and then we always want to reduce as far as possible. So 30 over 180, 3 over 18 would reduce to 1 over 6. So I could just write that as 1 pi over 6. And we do always want to leave these in terms of pi if applicable, right? If for some reason there was this was over pi and the pi's canceled, that would be okay. But if a pi ends up in our final answer, we want to leave that. We don't want to put 3.14 divided by 6 into the calculator. We want to leave this as pi over 6. So we would say that a degree measure of 30 degrees is the same as pi over 6 radians. Okay, let's try another. Okay, so if we do negative 225 times pi over 180, negative 225 pi over 180, and again, we just want to reduce that as far as possible. Now, know that the calculator can do that for you, right? If you hit the math button, and then the first option is frac, right? So if I just put 225 divided by 180, then math 1, it'll put the fraction in lowest terms for me. So this would just be equal to negative 5 pi over 4. Okay, and so for that, I just put the 225 over 180 into the calculator. I did not include the pi because I know that's just going to get tacked on at the end. Okay, one more in this direction, right? So again, if I'm multiplying by pi over 180, that would be 55 pi over 180, and I can just put 55 over 180 into the calculator, and it'll simplify it for me, right? As long as I hit math 1. So this would just simplify to 11 pi over 36. All right. Then, finally, let's convert from radians to degrees. Okay, so if I want to go the other way, I would take this conversion factor and divide both sides by pi. So to convert from radians to degrees, I'm just going to multiply by 180 over pi. All right, so if I take pi over 3 times 180 over pi, well, the pi's would cancel, and I would just be left with 180 over 3, which would be 60 degrees. So an angle of pi over 3 radians is the same as 60 degrees. Okay, let's try another one. Negative 2 pi over 5. So again, I'm going to multiply this by 180 over pi. Negative 2 times 180 would be negative 360 over 5. The pi's will cancel. And negative 360 divided by 5 is negative 72. So negative 2 pi over 5 radians is the same as negative 72 degrees. Final example here. Right, let's say we just have 1 radian. Okay, this isn't in terms of pi, it just says 1 radian. How many degrees is 1 radian? And remember, what this means visually is if I were to take 1 radius length and put it around the edge of the circle, how many degrees is that? Okay, well, if we think about our conversion factor, we said I'm just going to take the number of radians times 180 over pi. So 1 times 180 over pi, we can use the calculator for that. So 180 divided by, and pi is right here on your calculator. It's second caret. So 180 divided by pi is about 57.30 degrees. Okay, if we go to 2 decimal points. So 1 radian It's about 57.30 degrees. All right. So sometimes, okay, if this isn't in terms of pi, we may end up with a decimal. Okay, the pi, there was no way to cancel out any pi's here. All right. So that is it for this lesson. The final question is going to pop up asking you what questions you have.